I had ended the previous lecture by asking you to think about what the bug was in this code. Now, many of you would have looked at the mathematical definition on the left and the code on the right, and you would have probably seen that there is a difference in the case when n is odd, right? So in the mathematical definition, we have in the exponent n minus 1 by 2. But on line 6, which corresponds to the case when n is a odd positive integer, we are calling the power function with the second argument n by 2, not n minus 1 by 2. So that seems to be the bug. But is it really an error? So let's look at an example n, which is odd and positive. So how about n equal to 5? So mathematically, when we want n minus 1 by 2, we are talking about the answer 2. But what are we calculating on line 6? We are calculating int n. Remember, n is an integer parameter. Int n divided by int 2. So integer 5 divided by integer 2, and that is integer division. Now remember, integer division truncates. So although 5 divided by 2 is 2.5 mathematically, with integer division this would be truncated to 2. So that's the same answer. And it turns out that actually there is nothing wrong with this code from a correctness point of view. But this code is really, really slow. Now, some people will say, well, in that case, you shouldn't call it a bug. Well, some people also like talking about performance bugs. This code has an obviously wrong way of doing calculations. So let's understand this. Let's look at, say, line 4. On line 4, we are calling the power function twice. Nothing wrong with that. But we're calling the power function twice, and in both cases we're calling it with the same arguments. So what are we doing? We're saying calculate power x comma n by 2, and that takes some number of steps, and it produces an answer. Then we're calling power x comma n by 2, the same arguments, and we're redoing the same calculation. Why are we doing the same calculation twice? It seems wasteful. It seems much simpler to calculate that answer once and save its value, and then take that saved value and square that, multiply that value by itself. So that's the trick we should be using on line 4, and of course we should be using the same trick on line 6. And that's the trick I'm going to show you now. I'm going to take you over to my IDE, and this is the old code. I'm actually going to run it because in my main program, I am calculating 1 to the power 2000, which is just 1, and I'm calculating this 2000 times and adding the values up. So I should get the answer 2000, which is what I get, but it took my computer almost 11 seconds to calculate that. So now let me try and do this idea that I was talking about. I don't want to calculate this answer here and then calculate the same answer over here. That's wasteful. Instead, I want to calculate it once and save it in a variable. So let me declare a variable. It's going to have type double because the power function returns a value of type double. And I'm calculating x to the power half of n. So let me call this variable, say, half power. And I want to set its value to this call to the power function. So I'll calculate this value once and save it in this variable. But now I will take that saved value and multiply that saved value by itself. So you see that I have only called the power function once, and I'm using that saved answer. Now I'm going to do exactly the same trick in the else case. And once again, I'm going to take this saved answer and multiply it by itself. In this case, I also have to add the extra multiplication by x, so that I keep exactly as it is. So instead of 11 seconds, let's see how much faster this code is. Less than a second. Now, of course, I chose this example to be really, really impactful, but we have just seen something really, really important in coding and in computing. So let me explain this to you very, very carefully by introducing some terminology. So we have just seen that instead of trying to calculate everything in one giant mathematical expression, it's sometimes much more efficient to break the calculation into steps. And sometimes that calculation is easier to understand rather than trying to read this giant expression. So there are two benefits here. The most important thing we have seen is that when you break calculation into steps, you need variables to remember the partial results. So variables are maintaining some information between the steps of the calculation. And for this reason, introducing variables and trying to do things in steps are two very, very closely related ideas. Whenever you're trying to do something in steps, you have to be saving the intermediate answers in variables. And this is something we haven't really been doing so far. When we've been talking about functions, we have these parameters, and we said that the caller puts values in them, and we are just doing some expression that we are calculating in terms of those parameters. Now we are going to start seeing code that looks quite different because it's going to work within the same function but do multiple steps within that. And we will make use of variables heavily. So when we are looking at what kinds of variables a function can use, there are really two types. Now, technically there are more than two types, but in this basic introduction, we're just going to focus on two types of variables. And what are those two types? Well, the first one we have seen. These are the parameters. And as I just said, parameters get their value from the caller. The caller calls your function with some arguments, and so your parameters have some values. And your function can use those parameters as variables, and it can modify those variables also. But the function can also declare what are called local variables. So this variable half power that we declared inside the power function was a local variable. Only the power function can look at that variable and modify it. And to set that variable's value, we use an assignment. We use a single equal to. If you notice, if you go back in this video and look at what I typed in the IDE, I said half power single equals something, and that is called an assignment statement. And that is not a double equal to. We're not comparing two things for equality. We are setting a value. We are assigning the value of that variable to some result that we, in this case, calculated by calling the power function. So these are the two types of variables that a function has access to. The other thing that is very important to remember is that by default, variables in C don't have any fixed initial value. They're uninitialized. Now, again, there are some exceptions to this that we will ignore for now. And so what's extremely important is that when you want to use a variable, you must make sure it has been set to a value that you know about, because otherwise when your code runs, that variable will always have some value, and next time your code runs it may have a different value. So if you're not careful, and we will see examples of what this can lead to, then your code can run differently each time you execute it, and certainly that's not something that we like to have. So variables have some value, and unless we have initialized it to something that we know, we cannot be sure what that value is. So these are some very important ideas to remember, and we will further explore this idea of calculating in steps in the next few videos.